Hello students, welcome to my channel CM Hub where you, me and chemistry connect with each other. This platform is a gateway for mastering chemistry. In the earlier episodes, we discussed few questions on stoichiometry and chemical bonding. In this episode, we will try to discuss question on chemical equilibrium. This is a question asked in the NEET examination 2024. Let us first look at the question. For a reaction 2A reversible B plus C, given Kc is 4 into 10 power minus 3. At a given time, the composition of the reaction mixture is given as concentration of A is equal to concentration of B is equal to concentration of C is 2 into 10 power minus 3 m. And what he is asking is, from this given data, which of the following statement is true or which of the following statement is correct. Now, to understand this question, what we need to know is the relationship between equilibrium constant and the reaction quotient. Technically, the formula to calculate the reaction quotient and the equilibrium constant is one and the same. But the difference is, when we talk of equilibrium constant, we are referring to the concentrations of the reacting species or the composite mixture at equilibrium. That means all the measurements with respect to the concentration are done at equilibrium. But when we talk of the reaction quotient, it is applicable to a given concentration at any given instant of time. Now let us take the equation once again. 2A reversible B plus C. Now the equation for equilibrium constant Kc is equal to concentration of product raised to the power of their coefficient. What is the coefficient here? 1. What is the coefficient here? 1. What is the coefficient here? 2. So concentration of B raised to the power 1, concentration of C raised to the power 1 by concentration of A raised to the power 2. Now what will be Q? The formula of Q is also same. B to the power 1, C to the power 1 and concentration of A to the power 2. That is what I said. Technically the formula is same. But here all the concentrations are at equilibrium. Whereas here it is at any given time. So now what is Kc value given? The Kc value is given as 4 into 10 power minus 3. Now we need to find out Q. Once we get Q, then we look at three different cases. What are those three cases? If Q is equal to Kc, that means if the reaction quotient is equal to Kc, then the reaction is said to be at equilibrium. Now if Q is greater than Kc, let us look at what Q is. If Q is greater than Kc, that implies the numerator is greater than the denominator. That means the product concentration is greater than the reactant concentration. And at any given instant of time, if the concentrations of products are more than the reactants, the reaction tends to go in backward direction. Now case 3. If Q is less than Kc, so here what is the reaction? The reaction proceeds in the backward direction. And what if Q is less than Kc? If Q is less than Kc, that implies the numerator is less than the denominator. That implies the concentration of the reactants is more at that given instant of time when compared with the concentration of products. So the reaction proceeds in forward direction. These are the three conditions that you need to remember. I repeat, if Q and Kc are equal, the reaction is at equilibrium. If Q is greater than Kc, the reaction proceeds in the backward direction at that given instant of time. It implies at that given instant of time, the product concentration is more than the reactant concentration. Therefore, the reaction proceeds in the backward direction. If Q is less than Kc, that implies the product concentration is less than the reactant concentration at that given instant of time. So reactants being more, the reaction tends to proceed towards the formation of products, that is forward direction. So now let us calculate the Q value here. What are the concentrations given? All the concentrations A, B and C are given as 2 into 10 power minus 3. So now what is the formula? Q is equal to B concentration to the power 1, C concentration to the power 1, A concentration to the power 2. All of them are 2 into 10 power minus 3. So 2 into 10 power minus 3 to the power 1, 2 into 10 power minus 3 to the power 1. Now in the denominator it is 2 into 10 power minus 3 to the power 2. So all the 3 get cancelled. So now Q becomes equal to 1. What is Kc? Kc is 4 into 10 power minus 3. So Q is far greater than 1. When Q is far greater than 1, that implies the reaction proceeds in the backward direction. Let us look at the options. Reaction is at equilibrium, not possible because Q is not equal to Kc. Reaction has a tendency to go in forward direction, not possible because Q is greater than Kc. Reaction has a tendency to go in backward direction. This is the possible one because Q is greater than Kc. Reaction has gone to completion in forward direction. Reaction is set to go to completion when Kc is far greater. When Kc value is very large, then the reaction is set to go towards the completion in the forward direction. So what are the important concepts that you need to remember here? The important concepts that you need to remember here is the relationship between Q and Kc, where Q refers to the reaction quotient, which implies the concentrations are applicable at any given instant of time. You can use the concentrations of the composition mixture at any given instant of time, where Kc refers to the equilibrium constant. That implies the concentrations of the composition are always measured only at equilibrium. If the reaction is not at equilibrium, then it cannot be called as Kc. So I hope you understood this relationship between Q and Kc, and the answer for this is option 3. There is one more problem on chemical equilibrium which was asked in the same year, that we will discuss in the next episode. Take care. Bye bye.